Yeah, that seems correct to me.
Football is kicked off the ground a distance of 50 yards downfield, neglecting air resistance. Which of the following statements would be incorrect when the football reaches the highest point?
It still has horizontal velocity, so yeah, it's still
good. Mm-hmm.
It's vertical.
Remember these fun things. We have acceleration down, but velocity to the left or to the right.
You can actually say its vertical kinetic energy is 0. Or you just say it still has
just its kinetic energy is. Yeah.
That one wasn't that bad.
No. So 10 is A.
Energy would be at its lowest level in the air because it only has the horizontal velocity.
Exactly.
All right,
11. We can do that. 11.
Mass N established spring with spring concentrate mass in motion by displacement D from its equilibrium position will be a speed V of mass and returns to equilibrium position.
The work is equal to the change in energy. Start off with that, but also could be, since we're focusing on speed. Oh my god. What was that? It's oh my god. What does that mean? Yeah. So we're focusing
So, all right, so good. I am very proud of you for instinctively going to this equation, delta
You almost wrote it wrong.
delta E, right? So yes, good, do that. But the next problem is, does that answer the question?
no, because we're focusing on
Right. So all we're doing is we're trying to figure out what is the energy, how does the energy change in the system?
what is kinetic energy of the system?
We have mass and velocity, so what kind of energies are we probably going to be dealing with?
Kinetic energy.
Okay, but we also have K and D, so what kind of energies are we dealing with? Spring. So we have two different kinds of energies here. What kind of energy do you have in the beginning?
In the beginning is in.
Well,
It's set into motion, so if it's,
So kinetic energy.
so we have KEI in the beginning, and that must be equal to
1/2 mass times velocity squared.
no. I mean yes,
Oh, but equal to the potential spring energy.
spring potential energy.
which is 1/2 K displacement squared.
Exactly.
So 1/2 mv squared is equal to 1/2 K displacement squared.
So we just get rid of the 1/2,
Yeah.
Mm-hmm. By fraction.
divide by mass,
Mm-hmm.
And then square root.
solving for velocity, right? Yeah.
Mm-hmm.
So velocity is equal to the square root of kx squared over.
X times K.
Yeah.
Awesome.
So then that would be answer B.
Oh.
B. Mm-hmm. So because a lot of you are taking the PERT tomorrow, let's go through this. V squared equals kx squared divided by m. We take the square root of that, take the square root of that, and we get V equals, if I take this radical for this whole mess underneath it, it's the same thing as doing radical k times radical x squared divided by square root of m. Square root of x squared is what? Is x. So it's going to be square root of k divided by square root of m times x, which equals k over m
Dude, the camera
times
like
x.
lags behind your game.
I know, it looks like he's running around.
Yeah,
I just moved that fast.
He's
That's
turned
it.
into the Flash, dude.
Oh, so that's
Probably guaranteed that'll be under
Sound
PERT tomorrow,
effects.
somehow, somewhere.
Really? There's physics on the first?
That's not
That's
physics.
or is
No,
math.
math. Oh.
That's just algebra.
Putting physics on the
Game
script.
credits.
The physics happened right
Physics
here.
on the perk, dude.
Yes.
That's the
Say goodbye to
physics.
all the Finn kids.
That's your physics. The rest of it is just math. That's it.
Yeah, that's what you get.
This credits.
We're doing physics and math.
So I've got this equation called.
We're doing kinematics again in calculus.
Oh,
I sure do wish I was in calculus.
yeah, so do I. I'm drawing squiggly lines. We're doing physics.
Mason.
I've got an equation, so I just wrote it down from last night. Okay, work net net force is equal to 2m over velocity squared minus the initial velocity squared. Can't believe we just used that.
Network equals 2.
2m over velocity squared minus the initial velocity squared.
What is this from?
It's from last night on Khan
I
Academy.
think he means it's all on the bottom.
Khan Academy.
Yeah, all of it's on the bottom for the velocity.
Oh.
I see.
So it's
What is this for?
is that?
It was solving for it was dealing with spring, or not
spring.
Dealing with the cart.
Wait, what is N stand for? What is that?
And his mass.
Oh, work of net. Looks like nerve.
It's like for equation, a 2 kilogram cart was horizontally across a horizontal, like a frictionless plane with a distance of like 8 meters, so on and so forth. Like those types of equations. Are we allowed to use that?
You can use anything that you want as long as it's valid.
Gotcha.
I'd be interested in seeing the derivation of that. How you would get your velocities in the denominator.
I'm following Khan Academy. That's all I'm gonna do.
Just make sure you didn't
Not seen Khan
make a mistake or
Oh, yeah, all those just happened.
Yeah, no, I
last
saw
night.
them.
Number 12, I think we're on.
Yeah.
Fan blows the air and gives it kinetic energy. After an hour, the fan has been turned off. What happened to the kinetic energy of the air? Obviously, it just disappeared, right?
Yes.
Is it an isolated system?
Nope.
No, it's not an isolated system. It couldn't be because you have the motor moving,
So sound.
the blades, and then the blades moving the air out. So,
Wait, so is it
I wouldn't
actually
say it's-
egg? Like, are you being serious?
no,
Okay,
it's
thank God.
Turns out it's.
What's the
I want to
question?
say sound because it wouldn't turn potential energy, right?
a fan blows the air and gives it kinetic energy.
Right.
An hour after the fan has been turned